Greetings, and thank you for joining us on the Sleep Science Top 1. This evening, we embark on a journey into the remarkable and timeless realm of geology, where the profound history of our planet is etched in stone. Long before the stars received their names, or the oceans were defined by borders, the Earth thrived, quietly transforming itself. Mountains ascended and eroded, seas appeared and disappeared, continents drifted over radiant oceans of stone. The Earth below is timeless, unfathomably old. Yet, it continues to shift, to pulse, to evolve. This narrative unfolds the tale of geology, a saga of fire and water, of creation and destruction, of beauty that reveals itself over millions of years. Underneath each step, among every stone, echoes of ancient volcanoes, glaciers, and distant stars linger. If you appreciate these serene travels, I encourage you to like, subscribe, or share your thoughts in the comments below. It assists others in discovering their path here as well, one drowsy individual at a time. At this moment, simply take a breath. Allow your eyelids to feel weighted, and permit the timeless Earth to embrace your mind. Let's get started. The crust of the Earth is not as thick as one might think. If the planet were reduced to the size of an apple, the crust, which is the solid outer layer we inhabit, would be as thin as the skin of that fruit. This concept seems nearly unattainable, but it is indeed a reality. The continents and ocean floors combine to create a layer that typically reaches an average depth of around 30 kilometers beneath land and less than 10 kilometers beneath the sea. Underneath is the hidden molten sea, an extensive area of gradually moving rock that constitutes the majority of Earth's volume and mass. The crust drifts upon the hidden molten sea, resembling delicate rafts navigating through molten flows, influenced and molded by the movements of dancing continents. Mountains, valleys, and ocean trenches are mere blemishes on the vast expanse of a colossal stone sphere. All that we understand, every woodland, urban area, and sea, rests upon a layer so delicate it might nearly vanish in proportion. Ancient frozen fire once moved like liquid streams far beneath the Earth's surface. Long before it solidified into the tough stone we recognize today, ancient frozen fire was vibrant with heat. Deep within the planet's thin skin, molten magma collected in concealed chambers, flowing like sluggish rivers of fire. Over millions of years, it gradually cooled and crystallized into the recognizable speckled rock that now constitutes the core of mountains. Every grain of quartz and feldspar once sparkled in a molten radiance before becoming solid for eternity. As you glide your fingers across the surface of ancient frozen fire, you connect with the solidified remnants of a primordial flow captured in a moment from the past. Numerous remarkable landscapes across the globe, such as the cliffs of Yosemite and the Scottish Highlands, were formed by ancient frozen fire that ascended and solidified beneath the Earth's surface. It embodies the patience of the Earth, serving as a reminder that what seems solid now was once liquid light, gradually changing under immense pressure into something lasting and timeless. Instant cosmic jewels can form in an instant when the conditions are favorable. Instant cosmic jewels typically require billions of years to form deep within the hidden molten sea, originating from carbon subjected to extreme pressure and heat. However, nature has a tendency to be unpredictable. Under extreme pressures, carbon can quickly transform into diamond. These abrupt changes occur deep underground, where the heat surpasses that of molten metal, and the pressures are beyond what humans can sustain for any significant duration. As volcanic eruptions occur, these precious gems ascend through slender channels of rock, known as kimberlites, conveying a narrative from the core of Earth's formation. Every diamond you observe, regardless of its size, once thrived in an environment of intense heat and darkness, capable of melting steel. Regardless of whether they took shape over eons or in an instant, every crystal embodies a moment when simple carbon transformed into something remarkable. They embody nature's flawless documentation of change, emerging from turmoil and force, ascending towards illumination through the fundamental structure of the Earth. Certain mountains continue to ascend at a pace quicker than the growth of your fingernails. Mountains seem timeless, yet they are filled with dynamic energy. Far below the planet's thin skin, tectonic plates exert pressure against one another, gradually elevating rock layer by layer. In the rising eternal peaks and certain regions of the Andes, this gradual collision continues to elevate peaks at a rate quicker than the growth of your fingernails. What appears to be solid is, in reality, a component of an infinite cycle of elevation and wear. Wind, water, and ice erode mountains bit by bit, while the powerful forces beneath the surface reconstruct them in a cycle that has unfolded for hundreds of millions of years. A mountain might appear still, yet if time were accelerated, you would witness it pulse, rising as tectonic plates converge. The stone underfoot might have previously lain on the ocean bed, elevated over ages. These colossal beings serve as a reminder that our planet is never at rest, perpetually in motion, continually transforming itself, even during our slumber. Whole continents drift like rafts upon liquid rock. The Earth below us floats on an unseen ocean of liquid stone. Below the crust is the hidden molten sea, an area so intensely heated that solid rock acts like a very sluggish liquid. The continents lie upon this hidden molten sea like massive rafts of solid stone, moving across it over the ages. They move, bump into each other, and drift apart at speeds of just a few centimeters annually. Yet over millions of years, these small shifts transform the planet. Oceans ebb and flow, mountain ranges emerge, and whole climates shift. The continents we recognize are wanderers, perpetually on the move, even if their travels remain unseen to us. This gradual movement is what once brought all land together into the supercontinent. Ancient united land, and will eventually reunite the continents once more. Our world pulses with life beneath its serene exterior, and we are travelers on its expansive shifting plates, gliding across geological oceans without sensing the movement. The surface of the Earth is in a continuous process of recycling due to dancing continents. No element on the surface of the planet remains unchanged. The continents and ocean floors we observe today are the result of a continuous cycle of destruction and renewal, referred to as dancing continents. When tectonic plates meet, peaks emerge. At the point of separation, new ocean crust emerges as molten rock rises to the surface. In various locations, a plate descends beneath another and submerges back into the hidden molten sea, where it melts to rejoin the Earth once again. The very seabed itself is created, expands, and vanishes over a span of tens of millions of years. Each grain of sand, each cliff, each volcanic plain contributes to this magnificent planetary cycle. Earth stands out as the only known world that undergoes such a thorough recycling process, harnessing the gradual forces of heat and gravity to maintain the youthfulness of its surface. The surface of the planet is in constant flux, perpetually shedding and renewing itself with a serene, elegant rhythm. The rising eternal peaks continue to rise in height each and every year. The rising eternal peaks soar majestically above the clouds. Their development started approximately 50 million years ago, when the Indian plate collided with the Eurasian plate, causing the crust to crumple like folded fabric. The collision continues to occur, elevating the mountains by several millimeters annually. The peaks seem eternal, yet their summits rise continuously toward the heavens, even as the wind and glaciers shape them away. Each tremor felt in the area, every profound earthquake, serves as a subtle reminder of the tremendous pressure that continues to exert its influence. These mountains are not remnants of history. They are the vibrant outcome of a continuous clash that started long before humanity came into being. The collision that formed Everest is still actively altering the landscape below countless individuals. The rising eternal peaks, in their quiet ascent, serve as a reminder of the Earth's enduring strength, patient, unyielding, and perpetually dynamic. shaping continents with the ease of molding clay. Continents move at a pace comparable to the rate at which your hair grows. The movement of a continent can be measured at a pace comparable to the rate at which your hair grows in a month. However, throughout geological time, that gradual movement transforms the entire surface of the Earth. Continents move across the hidden molten sea, propelled by convection currents originating deep within the Earth. The Atlantic Ocean expands slightly each year, whereas the Pacific gradually diminishes. In the distant future, maps we know today will be completely transformed. Africa is set to drift nearer to Europe, while Australia will shift northward, potentially leading to a future where the continents reunite into one vast landmass. This gradual movement links the fossils of prehistoric beings discovered in distant oceans and clarifies why mountain ranges on different continents have common beginnings. The earth beneath my feet seems firm, yet it is merely a fragment of a vast, ceaseless journey that has been ongoing since the dawn of our planet. The ocean floor is more recent in age compared to the majority of the continents. Under the surface, there exists a concealed realm that is perpetually transforming. Although the continents contain rocks that are billions of years old, the seafloor is quite young in comparison. At underwater birth belts, molten rock ascends, cools down, and creates new crust that gradually extends outward. As it moves, it ultimately descends back into the hidden molten sea of deep ocean trenches, where one plate glides beneath another. The recycling process ensures that no ocean crust endures for more than approximately 200 million years, a brief interval in the vast timeline of Earth's history. The continents, in contrast, are timeless entities that have remained above the cycle of destruction. Observing the planet's surface through time, you would witness the oceans emerging and receding, mirroring the cadence of a breath. The ocean floor serves as the pulse of our planet, constantly rejuvenating itself, illustrating that even the most profound and shadowy regions of Earth are vibrant with activity and transformation. Magnetic stripes on the ocean floor capture the historical reversals of Earth's magnetic field. On the expansive ocean floor, the rocks display a pattern reminiscent of a barcode. The alternating magnetic stripes indicate periods when the Earth's magnetic field changed direction, resulting in the north and south poles switching places. When new crust is created at underwater birth belts, the minerals in the lava orient themselves according to the Earth's magnetic field prior to cooling, thereby securing that alignment. After millions of years, a subsequent reversal causes the next band to point in the opposite direction. Scientists can trace the history of magnetic flips that span tens of millions of years by examining these stripes. This finding was crucial in validating the theory of dancing continents, illustrating the gradual outward expansion of the seafloor over time. Under the surface of the oceans exists not disorder, but a meticulously arranged account of the Earth's unseen powers, inscribed in rock by magnetism, heat, and the gradual rhythm of geological time. Rocks can indeed transform into magnets once they cool down from lava. When molten rock cools on the Earth's surface, an extraordinary transformation occurs. Small particles of iron and nickel within the rock orient themselves in accordance with the planet's magnetic field, resembling unseen compass needles. After the lava cools and solidifies, the magnetic directions become permanently fixed, capturing a snapshot of the magnetic field's orientation at that specific moment. Researchers examine these natural magnets to chart the changing history of the Earth's poles. Each shift, every meandering change of magnetic north, is recorded in rock, preserved as the Earth's molten surface cools and hardens. These magnetic fingerprints contribute to the evidence that geologists have gathered to demonstrate the movement of continents and the spreading of seafloors. Within each piece of volcanic rock, there exists a quiet testament to Earth's magnetic rhythm, revealing hints about past orientations and the unseen energies that molded the environment surrounding our planet. The memory of the planet is magnetic, inscribed in the iron core of stone. Each volcano on our planet is linked to an underground magma chamber. Deep beneath the surface, every volcano possesses a core, that pulses with fiery magma. The underground chambers of magma serve as extensive reservoirs of liquid rock, fueling eruptions that have the power to transform landscapes and alter climates. Some chambers are compact and shallow, while others are vast and profound, extending deep beneath the surface. Within them, crystals develop, gases ascend, and pressure accumulates until the rock above can no longer contain it. Then, with immense force, the chamber unleashes its wrath through fissures and openings, spilling lava and ash across the surface world. In the intervals between eruptions, these reservoirs stay concealed, gradually replenishing and transforming. Contemporary technology enables researchers to observe their forms through seismic waves, akin to how ultrasound works for the Earth. Every volcano is integrated into this profound network of respiration, serving as a reminder that beneath serene landscapes and dormant peaks, immense luminous realms of liquid rock lie in wait beneath the surface. Certain volcanic eruptions can persist for hundreds of thousands of years. Eruptions are not always characterized by sudden, explosive events. Some exhibit patience and determination, continuing for eons beyond what one can envision. When hidden molten sea plumes unleash significant quantities of magma, the outcome can be a flood basalt, an extensive flow of lava that persists for hundreds of thousands of years. These eruptions have the potential to cover vast areas with layers of solid rock. The Deccan Traps in India and the Siberian Traps in Russia stand as vast remnants of ancient volcanic activity. Throughout their dominance, they emitted a significant amount of gas and heat, resulting in a transformation of the planet's climate and a shift in the trajectory of life itself. As I stand on one of these hardened lava plains today, it's difficult to envision the molten rivers that once flowed to every horizon. They remind us that at times, the Earth transforms not through violent eruptions, but through the gradual, relentless cadence of flames, extending endlessly under the vast expanse of the sky. Dark, dense layers of basalt dominate the ocean floor. If you were to traverse the ocean floor, each footfall would rest upon basalt, a dense, dark stone forged in the depths of fire. It occurs when molten material from the hidden molten sea erupts at underwater birth belts and rapidly cools upon contact with seawater. The outcome is a wide, continuous layer extending over the ocean basins, resembling the planet's protective shield. In contrast to the lighter rocks found on the continents, basalt contains a high concentration of iron and magnesium, which contributes to its dark hue and substantial weight. The robust layers are in a constant state of renewal as the seafloor expands outward, while older sections descend back into the hidden molten sea to undergo melting once more. Every square inch of the ocean floor has played a role in this perpetual cycle of creation and destruction. Under the surface, basalt captures the tail of Earth's slowest shifts, with each layer of solidified magma creating the serene base of the planet's seas. Ocean pillow stones solidifies into forms resembling balloons beneath the water's surface. When lava erupts beneath the ocean, it cools rapidly, causing its outer layer to harden immediately, while molten rock continues to surge from below. This unusual procedure results in rounded forms that look like pillows or bubbles piled on top of one another. Ocean pillow stones, characterized by its smooth and bulbous formations, can blanket vast areas of the seafloor. Every pillow captures a moment of intense movement, illustrating the interaction between molten rock and cold seawater in a single instant. Ocean pillow stones discovered on land indicates that the region was previously submerged beneath deep waters. The view is haunting, yet stunning, as if the stone retains a memory of once flowing like liquid before being frozen by the cold embrace of the ocean. These formations are natural masterpieces shaped by time, evidence that even in the deep, shadowy recesses, the Earth's creative energies remain vibrant and active. Frozen volcanic glass is a type of volcanic glass that forms rapidly as it cools. During instances of intense eruption, lava can cool so quickly that crystals do not form whatsoever. The outcome is frozen volcanic glass, a natural glass that shines with a captivating dark allure. It possesses a smooth, sharp, and reflective quality, created when molten rock encounters cold air or water, solidifying in an almost instantaneous manner. For millennia, it has been valued by humans for its flawless edges, used in the creation of blades, tools, and decorative items. However, beneath its reflective exterior exists a narrative of profound transformation. Molten fire captured in a moment, heat turned into delicacy. Frozen volcanic glass is fragile, yet when it breaks, it unveils beautiful curved patterns known as conchoidal fractures, reminiscent of the original lava's movement. This gassy rock represents one of the most striking contrasts in the field of geology. Conceived in chaos, yet delicately poised, timeless, a spark of flame eternally captured in the quiet embrace of rock. Certain rocks contain bubbles that capture the ancient atmosphere of Earth. Within the smallest crevices of rock, researchers have uncovered microscopic air bubbles that have endured for millions of years. These preserved pockets serve as time capsules, encapsulating the chemical signature of the atmosphere from eras long gone. Through their studies, researchers gain insights into the gases that once permeated the atmosphere, the levels of oxygen that were present, the amount of carbon dioxide that contributed to warming the planet, and the ways in which volcanic activity or biological life influenced the equilibrium. Certain bubbles originated in cooling lava, while others developed within sediments or ice. Everyone holds a whisper of a primordial breath, a remnant of the atmosphere that once enveloped ancient woodlands, colossal creatures, or even the earliest beings to draw in air. To grasp such a stone is to possess a piece of the lost heavens, a fragile testament to the shifting atmosphere that links all life throughout the extensive timeline of our planet. Mountains that surpass Everest in height lie concealed beneath the ocean's surface. Deep beneath the ocean's surface, there exist mountain ranges that surpass the height of the tallest peaks on land. Along the underwater birth belts, vast chains of volcanic mountains extend for tens of thousands of miles, towering higher from their base to their peak than Everest does above sea level. These submarine ranges remain largely hidden, enveloped in darkness and extreme pressure. Yet they rank among the most dynamic areas on our planet. Lava consistently flows from cracks, gradually forming new mountains and depressions in a deliberate, unhurried manner. The tallest of these concealed giants, like Mauna Kea, when measured from its base below the ocean, exceeds even the magnificent peaks of the rising eternal peaks. They serve as reminders that a significant portion of Earth's beauty and magnificence remains hidden beneath the waves. Expansive, quiet realms of stone that expand and transform in the shadows, molding the Earth from beneath without ever seeing the light of day. The deepest point on Earth is almost as far beneath sea level as the altitude at which planes typically fly above it. In the depths of the Pacific Ocean, the deepest Earth abyss exists as a profound abyss. Should Mount Everest be placed within it, the summit would remain hidden beneath over a mile of water. The deepest known point of the trench, known as the Challenger Deep, extends to nearly 7 miles below the surface, nearly the same distance that commercial aircraft cover while flying over the planet. Down there, the pressure is overwhelming, powerful enough to compress steel. Even amidst the shadows, life persists. Unusual life forms emit a glow in the dark waters, flourishing amidst the mineral-laden sediments. The trench signifies a subduction zone, a region where one tectonic plate descends beneath another and returns to the hidden molten sea. It stands not only as the Earth's deepest point, but also as a remarkable source of rejuvenation for the planet. It serves as a reminder of the limited nature of the visible world in contrast to the immense expanse concealed beneath. The Earth vibrates with tiny tremors that go unnoticed. Even when the Earth appears completely calm, it is resonating with the subtle whispers of perpetual activity. Every day, countless minor tremors traverse the planet's thin skin, remaining undetectable to human senses. These micro-earthquakes emit small releases of energy as the Earth adapts to pressures originating from deep within. Researchers employ precise tools to capture these subtle sounds, producing intricate diagrams of moving faults and concealed magma currents. Collectively, they create a constant background noise that persists, the subtle rhythm of a vibrant world. This constant shaking indicates to geologists the locations of creeping faults, areas of increasing pressure, and the activity of volcanic systems. The calmness of the universe is a mere facade. Underneath every mountain, forest, and ocean, the Earth shifts in myriad subtle ways, whispering, creaking, and adjusting in gradual, hidden patterns that tell the tale of the planet's ever-moving spirit. Earthquakes have the power to reverse the flow of entire rivers. When the Earth trembles with significant intensity, the very terrain can shift its course. In the event of strong earthquakes, the ground may tilt or shift so suddenly that rivers are compelled to change their direction of flow. This unusual occurrence has been documented in instances such as the significant New Madrid earthquakes of the early 19th century, during which parts of the Mississippi River briefly flowed in reverse. The abrupt shift of the crust can elevate one side of a fault while lowering the other, resulting in the formation of natural dams or the deepening of valleys. For a fleeting instant, the strength of the Earth's inner dynamics can surpass the constant force of gravity that directs each droplet of water. As equilibrium is restored, the rivers etch fresh routes across the altered landscape. These instances showcase the incredible power of geological activity, illustrating that even a river, which seems so enduring and timeless, can be reversed by the Earth's profound, concealed forces. Certain faults can emerge quietly, without any noticeable tremors. Not every tectonic movement reveals itself through earthquakes or devastation. In specific areas of faults, the crust moves at such a gradual and uniform pace that there is no perceptible shaking at the surface. This subtle activity, referred to as fault creep, alleviates stress in minor, ongoing steps. It remains unseen to those positioned above, yet it can be quantified using devices capable of sensing movement as slight as a few millimeters annually. Certain faults in California and Turkey shift in this manner, moving effortlessly while adjacent segments stay secured and strained. The gradual movements might inhibit the development of more significant earthquakes in those areas, but they also shift stress to other locations. This delicate interplay of tension and release is integral to the planet's ongoing balancing act. Even in the absence of drama or noise, the ground beneath us is subtly shifting, quietly adjusting, as the Earth transforms grain by grain over the ages. The temperature of Earth's core exceeds that of the Sun's surface. At the core of the planet exists a sphere composed of both molten and solid metal, subjected to pressures that are truly beyond understanding. The temperatures in that location soar beyond 9,000 degrees Fahrenheit, competing with and even surpassing the visible surface of the Sun. The tremendous heat we experience is a result of the residual energy from the formation of the Earth, along with the ongoing decay of radioactive elements located deep within the planet. The core influences all, from volcanic eruptions to the magnetic field that protects life from cosmic radiation. Even if we cannot observe it directly, its movement whirls like a dynamo, producing unseen lines of force that reach deep into the cosmos. The inner core, composed of solid iron, rotates at a slightly faster pace than the planet that surrounds it, whereas the outer layer exists in a flowing liquid state. This concealed furnace serves as the core of the Earth, the energy source that sustains our planet with motion, heat, and steadfast endurance. A vast ocean could be concealed deep within the hidden molten sea. Deep below the surface, where the rock radiates heat and pressure, researchers have discovered minerals that hold significant quantities of trapped water. These findings indicate that a vast ocean's supply of water could be located hundreds of miles beneath the surface, trapped within crystalline formations. Instead of moving freely, if unleashed, This concealed reservoir has the potential to replenish the world's oceans numerous times. It is not a sea as one might typically envision, but rather a profound, hidden reservoir of the very essence that nurtures all existence. The shifting of tectonic plates can transport water deep into this domain, where it eventually resurfaces through volcanic eruptions and ascending columns of molten rock. This hidden cycle may hold significant insights into the reasons behind the existence of oceans on Earth. Even in the most solid rock, water manages to persist, biding its time within the Earth's hidden molten sea for ages. Inside underground caves, crystals have the potential to grow larger than a person. In the stillness of the night beneath the northern Mexican deserts, there exists a cathedral made of crystal. Deep within a silver mine lies the giant crystal cathedral, where translucent gypsum blades extend over 30 feet in length. Each one developed over hundreds of thousands of years in perfect stillness, sustained by the hot, mineral-rich water that once filled the chamber. As the water receded, the crystals stayed behind, shimmering like frozen moonlight in the moist atmosphere. Stepping into the cave feels like crossing into a different realm, crafted not from stone and flames, but from a gentle, exquisite harmony. The conditions necessary to form such structures are exceedingly rare, requiring a delicate balance of heat, saturation, and time. These massive crystals serve as a reminder that even the toughest substances on our planet can transform and evolve, provided there is sufficient patience. They represent the planet's most stunning embodiment of tranquility, molded by the passage of time. In Mexico's giant crystal cathedral, giant gypsum crystals shimmer beautifully. Far beneath the surface, in an environment where heat and humidity can quickly damage machinery, exists one of the most stunning locations ever discovered. The giant crystal cathedral, found by miners in 2000, features gypsum formations that are so massive they look like pillars of light. Some weigh many tons and extend across the chamber like enormous glass beams. The crystals, developed as mineral-laden groundwater, maintained a consistent temperature over hundreds of thousands of years, enabling molecules to organize themselves in flawless symmetry. As the cave was drained, the growth ceased, capturing the moment in time indefinitely. The heat and humidity are so intense that it's impossible for anyone to remain indoors for an extended period. For fleeting instances, adventurers have traversed the radiant surfaces of clear stone walls. This is a manifestation of geological artistry, shaped not by human hands, but by the passage of time, the flow of water, and the subtle chemistry inherent in the earth. Salt domes can break through rock in a manner reminiscent of slow-motion explosions. In areas where dense deposits of ancient salt are concealed under heavier rock, an unusual and potent phenomenon may take place. Over millions of years, the salt starts to move upward, driven by the pressure from the surrounding layers. While it is solid, salt acts like a thick fluid when subjected to significant stress. It ascends through the stone above, flexing and fracturing it, forming dome-like formations that can extend for miles in elevation. Salt domes can occasionally entrap oil and gas, creating reservoirs that have influenced entire industries. From above, they look like soft undulations in the terrain. Yet, hidden from view, they stand as immense structures of gradual change, silently transforming the planet. Everyone narrates the tale of ancient oceans that vanished ages past, leaving behind minerals that persist in their ascent, evidence that even the earth beneath our feet can move like a steady, relentless wave. Petrified wood is, in fact, quartz, formed atom by atom. What appears to be a fallen tree transformed into stone is, in fact, something much more unusual and fragile. When a tree is covered by volcanic ash or sediment, minerals transported by groundwater infiltrate its cells. Over the course of millennia, each minuscule component of wood is substituted molecule by molecule with quartz, maintaining every ring, knot, and fiber with impeccable precision. The outcome is a fossil that retains a wooden appearance, yet has a cold and heavy sensation when touched. At times, trace elements infuse it with shades of red, yellow, or green, creating a natural masterpiece within its grain. Grasping a piece of petrified wood feels akin to clutching a memory turned tangible, a once living entity now crystallized through the enduring passage of time. It reflects the essence of nature, reminding us that nothing ever truly vanishes. It merely transforms, preserving the narrative of existence encased in rock. Coal originated from ancient forests that became ensnared in swampy environments. Long before humans roamed the planet, expansive tropical forests blanketed much of the terrain. As these forests perished, their decaying trunks and leaves settled into swamps lacking oxygen, where the process of decay came to a near standstill. Strata of plant material accumulated, compacting under the pressure of its own mass. Over millions of years, heat and pressure converted that buried organic material into coal, a dense rock composed of concentrated carbon. Every fragment contains the essence of sunlight harnessed by plants from an ancient atmosphere. The combustion of coal unleashes that primordial sunlight again, a spectral revival of energy, preserved through the ages. The journey that brought it into existence narrates a tale of change, where life turned to stone and sunlight transformed into energy. Each piece of coal holds the essence of long-lost forests, the remnants of a world that has faded away, now transformed into shadowy, flickering veins beneath our contemporary existence. Oil is derived from the preserved remnants of ancient plankton that have been buried over time. Long before dinosaurs walked the earth, the seas teemed with tiny organisms. As those minuscule organisms perished, they descended to the ocean floor and blended with the mud, creating dense strata of organic sediment. For countless millennia, the immense weight of the ocean pushed them further down, subjecting them to heat and pressure, until their carbon-rich remnants evolved into liquid hydrocarbons. Enclosed in permeable stone, these primordial compounds transformed into the oil that fuels contemporary society. Each drop we consume once flowed through an ancient ocean, absorbing sunlight via the most basic life forms. The energy that powers our planet originates from the sunlight of Earth's ancient history, preserved beneath layers of rock. The narrative of oil encompasses not just geology, but also biology, chemistry, and the passage of time, intricately intertwined in the silent depths beneath the earth, poised for revelation. Each grain of sand narrates the tale of a lost mountain. Every minuscule grain of sand was once part of something much more significant. Long before it found its place on a beach or in a desert, it was once a component of a majestic mountain or an age-old bedrock plain. For millions of years, the forces of wind, water, and ice have worn down that rock to its tiniest fragments, transporting them across rivers and oceans. A solitary grain could have journeyed through glaciers, navigated canyons, or sailed across oceans before finding its final resting place. When examined closely, its form and makeup disclose the type of rock it originated from and the path it has traveled. Certain grains continue to glimmer with remnants of quartz from long-lost continents. Some are remnants of volcanic eruptions that occurred long ago. Each handful of sand tells a tale of time, a gathering of shattered realms, transformed into sparkling pieces that will eventually be compressed back into stone, beginning the cycle anew. The sand of the desert can produce a low musical note as it shifts and moves. In certain unique deserts, the movement of sand dunes produces a profound, echoing hum that can endure for several minutes. The desert singing sands, located in regions such as Morocco, Chile, and the Arabian Peninsula, emit notes so pure that they resemble the very voice of the earth. The sound emerges from numerous grains, moving and crashing together harmoniously, resonating at a pitch that lies between the deep notes of a cello and the powerful rumble of thunder. Researchers assert that the grains need to be almost identical in size and completely dry for this phenomenon to take place. Travelers characterize the experience as eerie, as if the dunes are alive, whispering or exhaling. Ancient cultures frequently regarded these sounds as enchanting, convinced they originated from concealed spirits or deities of the desert. Ultimately, it is the interplay of physics and friction that transforms the landscape into a natural instrument, producing the gentle, enduring melody of the Earth's gradual movements. Certain beaches consist solely of small shells. Along specific coastlines, the sand underfoot was not shaped by stone, but created by living organisms. For centuries, the shells of numerous tiny marine organisms, including mollusks and foraminifera, have disintegrated into such fine fragments that they appear similar to powdered ivory. These biological sands can shine white under the sun, sparkle pink from crushed coral, or even radiate golden from the remnants of microscopic algae. Every grain represents a remnant of life that once existed, a part of the ocean's history brought back to the beach. Strolling along that beach feels akin to traversing the remnants of unseen realms, where the ebb and flow of the ocean have transformed the structures of existence into a gentle, ever-changing fabric. The renowned white beaches of the Bahamas and Maldives stand as testament to the fact that time and nature can create beauty just as effectively as geological forces. On Earth, you can find sands in various colors, including black, green, pink, and even red. Some beaches do not glisten with golden or white sands. Some are darkened by cooled lava. Others are vibrant green due to olivine crystals, pink from coral, or red from weathered volcanic rock. Every hue narrates a geological tale about its origin and the powerful forces that molded it. Volcanic islands are frequently bordered by black sands, created when molten lava encounters the ocean and breaks apart into small, glassy pieces. Green beaches emerge when unique minerals from deep within the hidden molten sea are brought to the surface by the waves. Pink shades arise from a blend of crushed shells and coral combined with white sand, whereas red sands are colored by iron-rich rock that has oxidized over time. Strolling along these vibrant shores feels akin to meandering through the very palette of our planet. Each wave reshapes grains that hold the essence of fire, water, and time, merging the elements of the world into a living artwork that transforms and sparkles under the dynamic illumination of the sky. Glaciers shape the land, much like flowing rivers of stone. A glacier appears motionless, yet it is in constant motion. Throughout the ages, layers of snow build up and compress into thick ice, which gradually moves downwards, altering the landscape it encounters. These frozen rivers press against the mountains, carving out valleys, smoothing stones, and transporting debris over great distances. As they pull back, they create expansive U-shaped valleys, distribute boulders across the landscape, and form sparkling lakes that occupy the routes they once traversed. Glaciers leave their mark on almost every continent, evident in the polished ancient frozen fire domes of Yosemite and the sculpted fjords of Norway. Even now, glaciers persist in their steady task, wearing down ancient rock into fine dust that floats on the breeze. They are the creators of landscapes, masters of the elements, molding the earth piece by piece. Their quiet persistence serves as a reminder of the planet's fragile equilibrium, where even the iciest forces possess a strength capable of transforming the world. Certain glaciers shift rapidly, allowing their movement to be observed within just a few hours. While glaciers typically advance at a rate of inches each day, some flow with such speed that their movement can be seen within just one afternoon. These swift flowing rivers of ice advance when meltwater eases the surface below, minimizing resistance and enabling large ice sheets to glide forward with speed. In Greenland and certain regions of Alaska, researchers have observed glaciers moving forward at unexpected velocities, their broken surfaces creaking and splitting as they advance. From afar, the movement appears unfeasible, firm ice, acting like flowing rock. This movement possesses immense strength, altering landscapes and moving vast amounts of rock. As they advance, they also serve as a reminder that even in their icy immobility, glaciers are vibrant with movement. Observing one in motion reveals the very essence of time speeding up, as the gradual pulse of the earth is transformed into a striking, palpable rush. Ice, subjected to pressure, acts similarly to honey that flows slowly. Underneath the glacier's exterior, where the pressure is overwhelming and temperatures remain slightly below freezing, ice ceases to act as a solid. Rather, it moves seamlessly, not in a hurry, but gradually and steadily, folding and bending like honey flowing in slow motion. The ice crystals undergo deformation and shift relative to one another, enabling large sections to gradually move down the slope. The movement imparts a fluid grace to glaciers, enabling them to carve mountains and shape valleys over the course of tens of thousands of years. Given the appropriate circumstances, solid rock can exhibit this behavior, flowing over extensive geological periods. Observing ice change shape under pressure during laboratory experiments shows how matter can blur the distinction between solid and liquid. What seems rigid transforms into something flexible with the passage of time and the application of pressure. The most significant changes on the planet frequently occur not in explosive moments, but through the steady resilience of materials adapting to pressure over time. Fossils have the ability to preserve raindrops that descended hundreds of millions of years in the past. At times, the tiniest remnants of history endure within the stone. Scientists have discovered delicate impressions of raindrops on slabs of ancient sedimentary rock, revealing that these drops fell onto soft mud long before the existence of humans. Every small crater captures a specific moment in time. A tempest swept through an ancient terrain, its raindrops dispersing over a realm teeming with peculiar flora and primitive existence. In mere moments, the marks were concealed beneath fresh layers of sediment, trapping them in obscurity until the rock solidified. Upon re-exposure, the surface unveils a flawless impression of the climate from a bygone era. These fossilized raindrops serve as a reminder that even the most transient moments can endure indefinitely when captured by fate. Within a single stone, we can discern the remnants of a storm that concluded hundreds of millions of years ago. The cadence remains evident within the chronicles of the Earth's recollection. Certain fossils maintain soft tissues, including colors and feathers. For centuries, it was believed that fossils could only preserve bones and shells, the durable remnants of long-gone beings. However, findings from recent decades have uncovered something remarkable. In exceptional circumstances, even fragile tissues may endure. In specific types of rocks, researchers have discovered impressions of skin, muscle, and feathers, occasionally accompanied by traces of pigment that reveal the original colors of dinosaurs and birds. Fossils are created when water rich in minerals permeates the remains prior to their decay, substituting organic materials with stone. The outcome is a snapshot of existence transformed into a sculpture, maintained in flawless precision. Some even preserve tiny structures that suggest how these beings moved, breathed, and glimmered in the sunlight of their era. Holding a fossil connects us to distant worlds, allowing us to sense the warmth and vibrancy of life that existed hundreds of millions of years ago. First life builders provide evidence of the earliest known life forms on our planet. In the distant past, before the emergence of animals or plants, basic microbes constructed layered formations in the shallow waters of the seas. These structures, known as first life builders, represent the oldest living fossils on Earth. Mats of bacteria formed these structures by trapping and binding sediment, creating domes that gradually expanded toward the sunlight. Certain ancient examples date back over 3.5 billion years, positioning them as some of the earliest evidence of life known to exist. Interestingly, first life builders are still found today in a few isolated locations, like Shark Bay in Australia, where microbial communities persist in their gradual, rhythmic development. Observing one feels akin to gazing into the very beginnings of biology, at the moment when the first cells started to mold the Earth. They remind us that the narrative of life commenced not with action or intricacy, but with a sense of patience. Strata of vibrant film transforming light, water, and time into the essential basis of all that came after. At one point in time, the Earth was entirely covered in white during a global snowball event. Approximately 700 million years ago, our Earth was on the brink of freezing completely. Ice extended from the poles to the equator, encasing the oceans beneath layers of frozen surface and bouncing sunlight back into the cosmos. Volcanic activity is thought to have altered atmospheric gases and influenced solar energy, leading to the onset of this global deep freeze. For countless millennia, Earth existed as an expansive, quiet realm of ice, its surface shining white under a faint sun. Life persisted, concealed in pockets of liquid water beneath the glaciers or in proximity to volcanic vents. Ultimately, volcanic eruptions emitted a significant amount of carbon dioxide, leading to the retrapping of heat and resulting in a dramatic, global thawing of the planet. The resurgence of liquid oceans could have played a significant role in sparking an explosion of intricate life forms. Snowball Earth represents a monumental shift in the history of our planet, a dramatic near-extinction and revival etched in ice and fire. Volcanoes might have brought that icy era to a close with a surge of greenhouse gases. Throughout the severe global freeze, volcanoes persisted in their eruptions, releasing carbon dioxide into the atmosphere for millions of years. As the ocean remained encased in ice, this gas was unable to dissolve, as it typically does, resulting in its accumulation in the atmosphere and the entrapment of heat. As the ice started to thaw, the pace of the melting increased significantly. Dark, bare rock soaked up the sunlight, intensifying the warming impact. In a brief moment, in geological time, the Earth transformed from a landscape of icy white to vibrant, steaming blue-green oceans once again. The melting ice led to floods, erosion, and possibly even chemical transformations that supported the emergence of early life. Volcanoes, in their own subtle manner, might have played a crucial role in preserving the planet, their steady presence beneath the ice sustaining Earth's climate. What was once a time of quiet transformed into a period of revival, demonstrating that even in the planet's deepest chill, warmth and rejuvenation were lying in wait beneath the surface. Ancient microbial mats were the first to produce oxygen in the air. The air we breathe is a result of the existence of tiny organisms that thrived billions of years ago. These microorganisms, the forebears of contemporary cyanobacteria, flourished in shallow marine environments and harnessed sunlight to break down water molecules, producing oxygen as a secondary result. As time passed, their waste changed the planet. Initially, the oxygen interacted with iron present in the oceans, leading to the creation of extensive deposits of rust-hued rock. It was only after these minerals reached saturation that the gas started to permeate the atmosphere, gradually transforming it into the essential mixture we rely on today. The event, referred to as the Great Oxidation, transformed everything. It enabled the evolution of complex cells, ultimately leading to the emergence of plants and animals. Each breath you take is a precious offering from those primordial microbes whose fundamental chemistry transformed a desolate planet into a vibrant one, laying the foundation for forests, oceans, and everything that came after. Iron formations signify the time when the Earth started to exhale. Across ancient seabeds globally, there exist layers of red and grey rock that glisten with a metallic sheen. These Earth's first breath rocks represent the fossilized evidence from the period when oxygen first emerged in Earth's atmosphere. When primitive microbes started generating oxygen via photosynthesis, this gas interacted with dissolved iron in the oceans, forming rust-like minerals that accumulated in layers on the seafloor. Over millions of years, these sediments solidified into rock, preserving the essence of a planet that was just beginning to awaken. Currently, those identical formations are extracted for iron, which serves as the foundation of contemporary industry. However, they originated as a result of tiny organisms. Every stripe in the stone represents a heartbeat in the planet's evolution, signifying the gradual shift from a lifeless world to one teeming with oxygen, where the very essence of life began to emerge across land and sky. Ocean. Once upon a time, the seas were a vibrant shade of purple, Prior to the presence of oxygen in the atmosphere, the appearance of Earth's oceans was markedly distinct. The water might have glimmered in hues of red and violet, tinted by ancient microbes that utilized sulfur molecules rather than oxygen to harness sunlight. These organisms flourished in chemically abundant seas beneath an orange sky, generating pigments that colored the water with unusual shades. As photosynthetic bacteria started to emit oxygen, these purple oceans gradually transitioned to the blue we recognize today. The transition from a sulfur-dominated world to one rich in oxygen stands as one of the most significant changes in Earth's history, transforming the atmosphere and the chemical composition of rocks. At one point, our world radiated hues that are beyond our wildest dreams. Vast expanses of violet beneath a muted sun, the hallmark of existence, playing with light long before the emergence of forests, coral reefs, or any air-breathing beings. Whole mountain ranges have disappeared without leaving a mark. The continents we observe today represent the most recent iteration of Earth's appearance. Throughout the vast expanse of geological history, entire mountain ranges have emerged and eroded to such an extent that not a single trace of them is left behind. Wind, water, and gravity operate steadily, eroding even the highest summits, bit by bit. The remnants of ancient mountains can occasionally be found as crystalline rock hidden beneath more recent layers, serving as hints for geologists to discover. Ancient continental crusts once supported towering mountain ranges, which have since transformed into expansive flat plains. Over the course of hundreds of millions of years, erosion can wear down a mountain just as effortlessly as waves polish a pebble. The Earth is in a constant state of renewal, and what appears everlasting to us is merely a fleeting creation in the continuous masterpiece of geological processes. Each plain and valley was formerly a peak, and every stone holds the spirit of a lost mountain within it. Throughout Earth's history, continents have repeatedly collided and separated. Throughout billions of years, the continents have come together and separated, resembling slow-moving puzzle pieces. The crust has continuously folded, fractured, and rearranged itself, propelled by heat emanating from the hidden molten sea. Every impact formed fresh peaks. Every divide unveiled vast seas. The supercontinent cycle has occurred repeatedly, at least 6 times. As continents converge, rocks are entombed and transformed anew by the forces of heat and pressure. As they pull apart, fresh crust emerges, bearing remnants of forgotten realms. The evidence of these migrations is evident in the corresponding fossils and rock formations discovered on either side of contemporary oceans. The Earth we walk on is not static. It is engaged in an eternal movement, a testament to the journeys it has undertaken, holding within its layers the stories of innumerable ancient civilizations. At least 6 supercontinents have existed prior to our own. Prior to ancient United Land, and even before Rodinia, the Earth underwent a cycle of assembly and disassembly at least 6 times, creating immense supercontinents that traversed through time. Every one possessed its unique mountains, oceans, and climates, with its own history of rise and fall, etched in stone. Nuna, Columbia, Rodinia, Panacea, and Gondwana represent the names of these ancient worlds, with their remnants dispersed throughout the Earth. During their existence, life was frequently microscopic, but their emergence significantly influenced the chemistry of the oceans and atmosphere. Every breakup and reunion changed the trajectory of evolution, influencing the climate and modifying the planet's deep currents. The continents we recognize today are fragments of those ancient titans, enduring remnants of a cycle that stretches across billions of years. Examining them reveals the story of our planet, chronicled through the ages, illustrating that even the very land is fleeting and nothing remains intact for an extended period. Ancient United Land was merely the latest supercontinent. Approximately 250 million years ago, almost all of the Earth's landmass converged into one enormous supercontinent, encircled by a worldwide ocean. This immense landmass, known as ancient united land, extended from one pole to the other, linking areas that are currently separated by vast oceans. The interior was unforgiving and arid, lacking the sea's soothing touch, whereas the coasts were alive with primitive reptiles and lush forests. For tens of millions of years, heat beneath the crust accumulated pressure until cracks emerged, dividing the land. The Atlantic Ocean widened, and the continents started to shift into their current locations. Fossils of the same plants and animals discovered on opposite sides of the ocean serve as quiet evidence of that long-lost connection. The fragmentation of ancient united land played a crucial role in forming today's geography and climate, laying the groundwork for all subsequent developments. This was neither the initial supercontinent, nor will it be the final one, just a single chapter in the infinite journey of Earth. A new supercontinent could be in the process of forming beneath the Pacific Ocean. Deep under the ocean, the gradual shifts of the tectonic plates are preparing for the next significant transformation of the Earth's landscape. Experts forecast that in 200 to 300 million years, the continents could potentially come together to form a new supercontinent. Certain models indicate that the Pacific Ocean may close as Asia and the Americas converge, resulting in a landmass often referred to as Amasia. Some envision the Atlantic narrowing, bringing Europe and the Americas closer together. While the result may be unknown, the journey is unavoidable. The same unseen forces that fractured ancient united land continue to operate, moving continents gradually, inch by inch. Envisioning the future reveals just how fleeting our maps really are. The Earth continually transforms, and beneath the surface, the initial movements of the next supercontinent are already in motion. Australia is moving northward toward Asia each year. Deep below the landmass of Australia, the tectonic plate that supports it is gradually moving northward at a rate of several centimeters annually. Throughout millions of years, this subtle movement accumulates to thousands of kilometers. In the future, Australia will come into contact with the islands of Southeast Asia, leading to the formation of new mountains and the alteration of coastlines. Satellite measurements currently monitor its annual drift with remarkable accuracy. The motion is driven by deep convection currents within the hidden molten sea, where heat from the planet's core shifts enormous sheets of rock as though they were floating on a molten ocean. While the movement may be undetectable to our senses, it has a profound impact on maps, climates, and ecosystems. Coral reefs develop in areas that were once terrestrial. Deserts gradually expand towards tropical zones, and in the future, new mountain ranges will emerge between these two landscapes. The gradual journey of the continent to the north is among the most elegant migrations found on our planet. Africa has the potential to eventually divide into two distinct continents. In the heart of East Africa, an immense rift extends for thousands of kilometers, signifying the location where the continent is gradually splitting apart. Evidence of volcanic activity, earthquakes, and a thinning crust indicates that a new ocean could eventually emerge in that area. The East African Rift serves as a clear indication that continents are not entirely stable. They flex and extend like a layer over a vibrant form. In several tens of millions of years, the area encompassing Ethiopia, Kenya, and Tanzania may detach from the remainder of Africa, moving eastward into a distinct landmass. Lakes like Tanganyika and Malawi occupy the deep scars of the rift, serving as early indicators of the ocean that will eventually inundate the area. Perched on its peripheries, feels akin to witnessing the dawn of a new landmass. The process unfolds at a pace that defies belief. It is occurring at this very moment beneath us, influencing the future we will inhabit. Iceland is positioned right above a fissure in the planet's thin skin. Iceland is situated on the mid-Atlantic ridge, which is a boundary where two tectonic plates are separating. In this location, molten rock spirals upward through an extensive fissure in the crust, creating new land as it solidifies. The whole island stands as a meeting point of flames and frost, Glaciers sit alongside active volcanoes, while hot springs, geysers, and lava fields reveal the dynamic energy beneath the surface. Occasionally, eruptions serve as a reminder to the locals that their land is still a work in progress. The island's distinctive location renders it one of the rare sites where this boundary ascends above sea level, enabling scientists to examine the fundamental mechanics of dancing continents in clear sight. Iceland serves as a dynamic showcase of nature's artistry, a realm where the Earth visibly evolves, teetering between the icy expanse of the North Atlantic and the fiery core of the planet. The Hawaiian Islands form a dynamic chain created by a fixed hotspot. A plume of molten rock ascends from the depths of the hidden molten sea in the Pacific Ocean, breaking through the crust to form volcanoes. As the Pacific Plate gradually shifts northwest, each eruption creates an island that subsequently relocates from the hotspot, making room for the next one to emerge. This process has resulted in an extensive series of islands and underwater mountains, extending for thousands of kilometers across the ocean floor. The youngest island, Hawaii, continues to radiate with active lava flows, whereas the oldest islands, located far to the northwest, have worn down into low atolls. By following this sequence, researchers can chart the trajectory of the Pacific Plate across millions of years. The hotspot remains stationary as the surface moves over it, creating a dotted trace of time and movement. Every island represents a segment in a continuous narrative of formation. Inscribed in liquid rock, Hidden Fire Heart conceals one of the most extensive volcanic systems on the planet. Underneath the forests and geysers of Hidden Fire Heart exists a vast reservoir of magma, substantial enough to sustain one of the most formidable volcanic systems ever identified. The park features steaming vents, bubbling pools, and dramatic eruptions of boiling water, all of which serve as surface indicators of the intense heat beneath. Researchers keep a vigilant eye on the area, charting the concealed passages that extend for many kilometers below the surface. While an eruption is not anticipated in the near future, its historical eruptions have significantly altered much of North America, dispersing ash over vast areas. Today, the area exudes energy through its geysers, releasing pressure in stunning eruptions that serve as a reminder of its core heat. Hidden Fire Heart serves as a haven of stunning beauty and a glimpse into the dynamic forces of our planet, where, beneath serene vistas, the age-old powers of heat and pressure quietly mold the Earth. Supervolcanoes have the potential to change the Earth's climate for hundreds of years. When typical volcanoes erupt, they influence local weather for several seasons. Supervolcano eruptions have the potential to change the face of the Earth dramatically. These massive explosions emit thousands of cubic kilometers of ash and gas into the atmosphere, obstructing sunlight and leading to a cooling effect on the planet that can last for decades or even centuries. There is clear evidence of these eruptions found in ash layers and climate records from Hidden Fire Heart, Toba, and Topa. The consequences involve volcanic winters characterized by falling temperatures and ecosystems facing challenges in adaptation. While uncommon, these occurrences serve as a reminder of the fragile equilibrium that exists between the Earth's interior and its surface. The energy confined below us has influenced the course of evolution, occasionally causing mass extinctions that paved the path for new forms of life. Even in their rage, supervolcanoes play a crucial role in the Earth's enduring cycle of renewal, transferring materials between the crust and the atmosphere, serving as a reminder of the profound connection between life and fire. The most significant volcanic eruption on record occurred in present-day Indonesia. Approximately 74,000 years ago, a massive eruption at ancient mega caldera in Indonesia transformed the planet. It released over 2,000 cubic kilometers of ash and magma, resulting in a caldera 100 kilometers wide that remains visible to this day. The explosion cast a shadow over the world, cooling the atmosphere and dispersing volcanic ash across various continents. Certain scientists propose that it triggered a short volcanic winter, which could have impacted early human populations. Long after the eruption ceased, volcanic gases remained in the atmosphere, coloring sunsets and contributing to a cooler planet for years to come. The event was so immense that it overshadows any eruption documented in history. Today, the serene lake that occupies the caldera appears tranquil, yet beneath its still surface rests one of Earth's most formidable marks, a testament to the fact that the planet's most significant instances of creation frequently arrive intertwined with devastation. Certain eruptions have deposited ash that continues to circulate around the globe, even now. Fine volcanic ash can linger in the upper atmosphere for years, propelled by winds that traverse the globe. Particles from significant eruptions, like Mount Pinatubo in the Philippines or Krakatoa in Indonesia, have been observed long after the explosions concluded. These tiny particles disperse sunlight, creating stunning red sunsets and contributing to a slight decrease in global temperatures. High above the weather, they create delicate layers that shimmer with light, reminiscent of the scenes that artists immortalized following monumental eruptions. Airborne ash can linger in the atmosphere for centuries, eventually settling back to Earth, where it is found in ice cores and ocean sediments. Each eruption, regardless of its distance, is linked to the atmosphere enveloping the whole planet. The air we breathe today holds remnants of ancient eruptions, a subtle reminder that even the most serene sky reflects the Earth's tumultuous past. Lava lakes have the ability to stay in a molten state for decades without experiencing any cooling. In certain unique volcanic craters across the globe, molten rock remains in a liquid state indefinitely. The lava lakes found in locations like Erta Ale in Ethiopia and Kilauea in Hawaii are maintained by a continuous influx of heat and magma from beneath the surface. Their surfaces churn and ripple like fiery oceans, crusting over only to break apart again. At night, they illuminate like portals into the planet's core, their orange glow dancing against the dark stone and swirling smoke. The heat balance is so precise that the lakes can persist for decades, continually refreshed by deep circulation. Observing one is captivating, a living furnace, breathing and pulsing in slow rhythm. They provide scientists with unique insights into the chemistry and physics of magma that cannot be duplicated in laboratory settings. Each lake is a reminder that the Earth's fire still burns just beneath its thin, cooling crust, timeless and alive. Lightning is capable of striking within volcanic ash clouds. When a volcano erupts, the immense friction between ash particles creates powerful electrical charges. As these charges build, they discharge as lightning bolts that crackle through the ash plume. Volcanic lightning can illuminate entire skies, creating storms of fire and light above erupting mountains. Unlike ordinary thunderstorms, these flashes are born entirely from the energy of rock and gas. Photographs capture branching bolts arcing through columns of black smoke, each strike lasting only a heartbeat, but carrying immense power. Scientists study these flashes to understand the flow of ash and to track eruption intensity, since lightning can signal how violently material is being ejected. To witness one is to see the fusion of Earth's elemental forces, solid, liquid, and gas-meeting electricity. A brief, awe-inspiring display that reveals how even destruction can shimmer with extraordinary beauty. When volcanoes meet ice, they create explosive steam eruptions. In places where glaciers rest atop volcanoes, heat and ice collide in spectacular ways. When magma rises beneath the ice, it melts huge volumes of water in an instant, producing steam that expands with explosive force. These eruptions can blast through the glacier, sending floods and ash clouds cascading down valleys. Iceland's volcanoes often behave this way, hidden beneath thick ice caps until pressure builds high enough to burst free. The interaction leaves behind unique landforms, ridges and plateaus sculpted by fire and water together. Scientists call them tuias, monuments to the strange partnership of heat and cold. Each eruption beneath ice rewrites the landscape, proving that even the most opposite elements of nature are connected in a cycle of creation and transformation that has shaped our planet since its earliest days. Entire new islands have risen from volcanic eruptions within living memory. Across the oceans, new land sometimes appears where there was once only water. Submarine volcanoes occasionally erupt with such force, but they build islands from the seafloor upward. In the past century, eruptions near Iceland, Japan, and Tonga have created fresh patches of land that still steam and harden under the sun. Some vanish again within years, eroded by waves, while others grow stable enough to host life. These newborn islands reveal the planet's creative power unfolding in real time. To watch one form is to witness the process that built continents long ago. Birds, plants, and eventually humans find their way there, turning raw lava into ecosystems. The emergence of new islands reminds us that Earth is not finished with its work. The planet continues to build, break, and begin again, renewing its surface one eruption at a time. Some lakes are filled with dissolved carbon dioxide that can erupt like soda. In parts of Africa, certain deep lakes contain massive amounts of carbon dioxide trapped beneath their surfaces. When the balance of temperature or pressure changes suddenly, that gas can burst upward in a deadly invisible wave. Lake Nyos in Cameroon released such a cloud in the 1,980 seconds, suffocating life in nearby valleys. Scientists now monitor these lakes carefully and install systems to safely release gas before pressure builds too high. The phenomenon is called a limnic eruption, a rare but powerful reminder of how even tranquil waters can conceal immense energy. The gas originates from volcanic sources below the lake bed, seeping upward through cracks in the crust. Over centuries, it dissolves into the water like carbonation in a bottle. When it finally escapes, the result is silent and shocking, a natural event as strange as it is terrifying. Sinkholes can swallow buildings in seconds. Beneath many cities and fields, hidden cavities form where limestone or salt dissolves slowly in underground water. When the roof of one of these voids collapses, the ground above can suddenly drop away, creating a sinkhole. Some are only a few meters wide. Others can stretch hundreds across, devouring cars, trees, and homes without warning. They form most often after heavy rain, when water seeps through cracks and weakens the layers below. Entire neighborhoods have been built atop such fragile foundations without realizing it. Scientists map vulnerable regions with radar and ground sensors to detect cavities before disaster strikes. Though dramatic, sinkholes are part of the planet's natural recycling of rock, where water patiently sculpts the landscape from beneath. Each collapse reveals the fragile balance between solid ground and the hidden hollows that lie quietly just below our everyday world. Karst landscapes hide secret rivers flowing through stone. Where limestone or dolomite dominates the bedrock, rainwater slowly carves intricate networks of tunnels and caverns. These underground systems can stretch for hundreds of kilometers, carrying entire rivers beneath the surface. The land above collapses in places, forming sinkholes, valleys, and jagged ridges, characteristic of karst terrain. Water disappearing into a cave entrance might re-emerge miles away as a clear spring. In some regions, entire ecosystems have adapted to these lightless waterways, from blind fish to translucent insects. Karst landscapes are found on every continent and provide drinking water for millions of people. Yet their hidden nature makes them vulnerable to pollution. Exploring them is like entering the circulatory system of the planet, where stone and water move together in endless dialogue, dissolving, shaping, and renewing the surface of the earth, drop by drop. Stalactites grow from the ceiling, stalagmites from the floor, and they can meet to form pillars. Inside limestone caves, dripping water carries dissolved minerals that slowly crystallize as it evaporates. From the ceiling, each proplet leaves behind a tiny ring of calcite that lengthens downward over centuries, forming the stalactite. Where the drops land, matching mounds grow upward as stalagmites. Eventually, they can meet to create towering columns that seem to hold the cave aloft. The process is so gradual, the growth rates are measured in millimeters per century. Lantern light reveals their delicate textures, frozen waterfalls sculpted by time and patience. These formations are living records of the cave's history, recording changes in water chemistry and climate. When viewed together, they resemble forests of stone, where every branch and trunk was born from a single droplet that fell through darkness, carrying the memory of rain and the passage of unthinkable time. Cave formations grow slower than fingernails. The breathtaking shapes found in caves are products of unimaginable patience. Stalactites, flowstones, and crystal draperies accumulate one layer at a time as water leaves behind thin films of mineral. A single centimeter of growth can take hundreds of years. The rate depends on the drip of water, the purity of minerals, and even the temperature of the surrounding rock. Some formations still glisten wet from drops that began their journey through the ground decades ago. Studying their layers allows scientists to reconstruct past climates, revealing droughts, floods, and shifts in rainfall patterns long before written history. Walking through a cavern is like entering a slow-motion clock, where time moves at the pace of minerals crystallizing. These subterranean sculptures remind us that beauty can emerge not from speed or force, but from stillness and persistence beyond human measure. Certain caves possess unique weather systems of their own. Deep underground, large cave networks can develop microclimates distinct from the surface. Temperature, humidity, and airflow combine to create fogs, winds, and even tiny clouds that drift through the chambers. Warm air ascending from deeper areas encounters cooler air at the entrances, creating swirling currents that mimic small weather fronts. Certain caves undergo a rhythmic process, releasing warm air during the winter months and drawing in cool air when summer arrives, responding to the fluctuations in external conditions. Moisture gathers on walls, trickling down to nourish fragile formations and ecosystems. Entering this space evokes the sensation of the earth taking a breath, where the harmony of air and stone intertwines seamlessly. These concealed environments safeguard fossils, artifacts, and species that are unable to thrive in other locations. Caves, with their stone lungs, serve as a reminder that even the most solid aspects of the earth are alive with movement, breath, and delicate patterns of a living atmosphere. The longest cave on Earth extends for hundreds of miles beneath the surface. Under the expansive hills of Kentucky rests Endless Underground Kingdom, recognized as the largest cave system in the world. The passages stretch over 400 miles, and new tunnels continue to be uncovered. The network was shaped by ancient rivers eroding limestone over countless years, twisting and turning in a maze that could conceal entire cities within its depths. Adventurers navigate through tight passages, grand caverns, and subterranean waterways that continue to sculpt the stone in the present day. The atmosphere is cool and tranquil, with a silence so profound it feels almost vibrant. The cave's immense scale captivates the mind, serving as a reminder of the countless wonders that lie hidden beneath our very feet. Endless Underground Kingdom stands as a remarkable geological marvel and a testament to the passage of time, shaped by the relentless flow of water into an endless stone cathedral that delves into the depths of darkness. Earthquakes have the potential to permanently alter the duration of a day. A significant earthquake alters the distribution of Earth's mass, leading to a slight change in the planet's rotation. The impact is minimal, typically quantified in microseconds, yet remains quantifiable. An earthquake can slightly change the planet's moment of inertia by shifting massive slabs of rock, similar to how a spinning skater accelerates by drawing their arms closer to their body. Following the 2004 Sumatra earthquake, researchers determined that the length of the day was reduced by mere fractions of a second. The event also shifted the position of the poles and altered the shape of the planet just a bit. These changes serve as a reminder that even the notion of a day, which seems definitive, is shaped by the profound forces of rock and gravity. Every quake transcends mere surface disturbance. It resonates throughout the planet, intertwining with the Earth's rotation and subtly altering the cadence of time. Shock waves from enormous earthquakes can circle the entire planet. When a significant earthquake occurs, the energy it unleashes extends far beyond the epicenter. Seismic waves spread out across the planet, moving swiftly through rock and hidden molten sea. Much like sound travels through a bell, delicate instruments are capable of picking up the same seismic wave, reverberating globally multiple times before it diminishes. The most powerful earthquakes cause the whole planet to shake, gently bending its crust as energy travels from one side of the Earth to the opposite side. Even areas located thousands of kilometers away can experience the subtle aftershocks. Researchers utilize these worldwide echoes to chart the Earth's interior, following the paths of the waves as they curve and bounce within the molten layers. Every tremor uncovers details regarding the composition of the deep Earth, indicating where it is solid, where it is fluid, and the movement of heat within. Each significant tremor momentarily transforms the planet into a unified, resonating entity, softly pulsating with its own rhythm. Certain earthquakes unleash energy comparable to millions of tons of TNT. The magnitude of an earthquake's energy is truly astonishing. The largest faults, when they rupture, can unleash energy equivalent to several million tons of explosive material detonating simultaneously. The tremors we experience on the surface represent just a fraction of the whole picture. A significant portion of the energy penetrates deep into the crust, shifting rock layers that are heavier than entire mountain ranges. The moment magnitude scale utilized by scientists today was developed to gauge these tremendous forces with greater precision than previous systems. In the 2011 Tohoku earthquake in Japan, the energy released was sufficient to change the planet's rotation and displace the seafloor by several meters. Understanding these figures can be challenging. Yet every tremor serves as a reminder that the planet's thin skin endures relentless pressure, perpetually accumulating and discharging energy in a gradual, forceful cadence that molds the land and oceans throughout the ages. Deep underground, rocks can behave like putty when subjected to pressure. While stone appears solid and unyielding to our senses, its behavior deep within the earth is quite different. In the profound depths, where temperatures and pressures escalate to unimaginable levels, rock starts to gradually deform, moving like an incredibly viscous liquid. Over millions of years, this plastic movement enables entire mountain ranges to rise, fold, and transform into new formations. Minerals extend and contort, forming patterns visible in metamorphic rocks that are currently exposed at the surface. In laboratory experiments, geologists have observed that samples of rock bend instead of breaking when subjected to heat and pressure, demonstrating that the passage of time influences the behavior of matter. The hidden molten sea below us is in constant motion, its currents propelling the continents above as they shift and drift. This serves as a reminder that even the most seemingly inflexible can move, and that the true strength of stone is found not just in its hardness, but in its capacity to adapt, transform, and withstand. Metamorphic rocks capture the narrative of pressure and heat within the Earth. When rocks are hidden deep within the planet's thin skin, they undergo a transformation. Intense heat and pressure rearrange their minerals without fully melting them, resulting in new textures and structures. Ancient frozen fire transforms into gneiss, limestone transforms into marble, and shale transforms into slate. Every kind of metamorphic rock holds a testament to the forces that molded it. Akin to entries in a geological journal, researchers have the ability to analyze these records to piece together the history of ancient mountain formation, as well as the depths at which specific rocks were once located. Certain metamorphic formations can indicate the direction of tectonic movement by showcasing their mineral alignments. As uplift brings them to the surface, we catch a glimpse of the planet's internal history, preserved in crystalline form. These are stones that hold memories, encapsulating the vast energies that silently course beneath the surface, revealing that every mountain was once concealed, reshaped by heat, pressure, and the passage of time. Slate originated as mud, transformed by the passage of time into stone. Underneath the primordial oceans, sediments of mud accumulated in serene obscurity. Over millions of years, these sediments were compacted by the weight of newer layers above, which squeezed out water and aligned clay minerals into flat sheets. Through the application of heat and pressure, the mud transformed into slate, a rock characterized by its fine layering, allowing it to be divided into smooth tiles. The journey unfolds as a tale of quiet resilience, where the calm of sediment evolves into enduring stone, slate, once constituted entire seafloors. Today, it covers cottages and borders pathways, bringing the essence of ancient oceans into our contemporary landscape. When you take a piece and angle it towards the light, the sheen of its compressed minerals becomes visible, revealing tiny remnants of clay that once floated gently in water. It demonstrates that even the gentlest substances can, over time and with pressure, transform into something lasting and resilient. Marble originated from limestone that contained sea fossils. Long before it shone in temples and sculptures, marble originated as simple limestone on the ocean floor. The limestone consisted of shells and skeletons from marine organisms. Coral, plankton, and mollusks have been compacted over millions of years. As it lay hidden beneath the Earth's surface, it encountered intense heat and pressure, which facilitated the growth of its crystals, eliminating any visible fossils and resulting in the sleek, interlocking texture characteristic of marble. Trace minerals introduced delicate hues: iron for red, serpentine for green, and graphite for gray. When refined, these minerals reflect light, bestowing marble with its renowned radiance. Ancient civilizations valued it for its ability to appear as if it contained sunlight. Indeed, it stands as a remnant of long-lost seas, created through the cycles of existence, demise, and change. Each refined surface of marble, whether it be a cathedral column or a sculpted statue, originated from a vibrant sea that solidified into enduring elegance. Each gemstone reveals the narrative of its formation within the Earth. Deep within the planet's thin skin, heat, pressure, and chemistry work together to form crystals of remarkable beauty. Instant cosmic jewels develop under immense pressure deep within the Earth, while emeralds form in mineral-laden veins, where water interacts with rock to exchange elements. Rubies, sapphires, topaz, and quartz emerge from specific conditions of temperature and chemistry that seldom align. That uniqueness makes them valuable. When cut and polished, their clarity unveils the harmony of their atomic structures, offering a glimpse into order crafted from chaos. Gemstones journey from the depths of the Earth to human possession via volcanic activity, erosion, and the passage of time. Every single one serves as a communicator from a distinct ecosystem on the planet, documenting its concealed workings. Gazing into a gemstone is akin to delving into the Earth's history, witnessing the enduring force of pressure and the beauty of crystallization expressed in flawless, shimmering harmony. Rubies and sapphires are essentially the same mineral, distinguished by the presence of different elements that impart their unique colors. Initially, rubies and sapphires may appear to be entirely distinct gemstones, yet they are both forms of the same mineral, corundum. Corundum, in its unadulterated state, is devoid of color and consists of aluminum and oxygen arranged in a densely packed crystalline structure. When small quantities of chromium infiltrate that structure, it emits a red glow and transforms into ruby. When iron and titanium assume their roles, the outcome is blue sapphire. Various trace elements can create shades of yellow, green, or even pink. The slight alterations in atomic structure influence how light travels through the crystal, resulting in the unique color of each gem. The existence of two of the world's most treasured stones, originating from the same mineral, illustrates how minor alterations at the atomic level can produce remarkable beauty. Each hue serves as a unique signature of chemistry, a testament to the fact that the beauty of nature originates from the unseen interplay of elements hidden beneath the surface of the Earth. Emeralds develop exclusively under the most unique circumstances of pressure and chemical composition. Emeralds stand out as some of the most elusive gemstones. A precise convergence of two distinct realms is necessary: silicic rocks and beryllium-bearing fluids, a scenario that seldom occurs in the natural world. When this occurs, the mineral beryl is formed, exhibiting a green hue due to the presence of chromium or vanadium traces. This intricate equilibrium takes place solely in specific mountainous areas, where tectonic movements have fused these elements together. The outcome is a treasure that holds the intensity of its creation in each glimmering surface. Many emeralds feature small fractures and inclusions, known as jardins or gardens, which signify their natural development. These imperfections are not defects, but marks of genuineness, proof that the stone is a genuine creation of nature. To possess one is to embrace the narrative of unlikely connections, tremendous force, and the slow passage of time that came together to forge something extraordinarily unique and radiant. Opal is created when ancient groundwater permeates silicic rock. Opal stands out from the majority of gemstones due to its non-crystalline structure. It occurs when water containing dissolved silica seeps through rock, leaving behind tiny spheres that accumulate in fine layers. These spheres disperse light, creating the distinctive rainbow shimmer of opal, referred to as play of color. Numerous opal deposits originated in dry environments that were previously moist millions of years ago. As the water evaporated, it revealed these detailed, radiant formations. When examined closely, opal unveils a realm of structure concealed within its seemingly chaotic appearance, presenting a natural tapestry of hues embedded in stone. Australia, renowned for its exceptional specimens, was once situated within an ancient inland sea where these processes took place. Each opal holds within it not just the light visible to our eyes, but also the echoes of departed rain, forgotten rivers, and the subtle alchemy that transforms water and sand into a flame eternally preserved in stone. Meteorites on Earth revealed tales from a time before our planet came into existence. When pieces of rock descend from the cosmos, they carry insights from the primordial era of the solar system. Certain meteorites originated billions of years ago, well before the existence of Earth, emerging from the identical cloud of dust and gas that led to the formation of the Sun and planets. These minerals have stayed the same since that era, maintaining a testament to the chemistry of the past. Researchers investigate them to understand how the fundamental components of planets came together, melted, and separated into cores and crusts. Some even transport organic compounds, suggesting that the building blocks of life were dispersed throughout space well before the formation of Earth. Holding a meteorite allows you to connect with something that predates our planet, a fragment of the universe that has journeyed through time and space to arrive in our grasp, holding the essence of creation within it. Certain rocks predate the very existence of the solar system. Scientists have found microscopic grains known as pre-solar dust within specific meteorites, which are remnants of ancient stars that predate the Sun. These minuscule crystals originated in the outer layers of expiring stars and were transported into space by stellar winds. For billions of years, they wandered through the galaxy, ultimately becoming ensnared in the matter that formed our solar system. Their isotopic signatures indicate their extraterrestrial origins, contrasting with anything discovered naturally on Earth. Finding grains within a rock is akin to uncovering stardust that has remained unaltered by planetary processes, a substance that existed before the formation of the Earth. As we examine these particles, we uncover narratives inscribed long before the dawn broke, the resonances of supernovae, and the gentle exhalation of red giants. Every grain carries a secret from the galaxy's history, a testament to the fact that Earth emerged from the remnants of stars that have come before. The lunar rocks returned by astronauts assist in determining the age of Earth's primordial crust. The samples gathered from the Moon during the Apollo missions provided insights beyond just lunar history. They revealed insights into the origins of our planet. The isotopic makeup of lunar rocks aligns with that of Earth's hidden molten sea, reinforcing the idea that the Moon originated from the remnants of a massive impact involving a young Earth and another planet-sized entity. Through the examination of those rocks, researchers were able to approximate the time when planet's thin skin first solidified, which occurred approximately 4.5 billion years ago. Certain ancient lunar basalts capture the impacts that influenced the formation of the early solar system. Their surfaces, marked by micrometeorite impacts, have stayed the same for ages, maintaining a record of ancient bombardment that has been lost on our worn-down planet. Each moon rock returned is a time capsule, uniting two realms eternally bound by a singular, tumultuous origin narrative inscribed in dust and flames. The most ancient minerals discovered to date are small zircons originating from prehistoric Australia. In the ancient rocks of Western Australia, geologists found tiny zircon crystals that are over 4 billion years old. These durable minerals emerged shortly after the formation of the Earth, enduring numerous cycles of erosion and transformation. Within each specimen exists a remnant of uranium that has gradually transformed into lead, enabling scientists to determine their age with remarkable accuracy. The composition of the zircons indicates that liquid water was present on the planet at the time of their formation, implying that Earth's surface cooled remarkably fast following its tumultuous inception. They stand as some of the rare remaining witnesses to the planet's primordial era, remnants that have endured the obliteration of vast landmasses. Viewing a zircon through a microscope allows one to witness the very beginnings of Earth's history, a crystalline reminder of an era when the planet was in the midst of shaping its oceans, crust, and atmosphere. These zircons capture the earliest presence of liquid water on Earth. The examination of those ancient zircons showed chemical ratios that align with rocks that had come into contact with liquid water. The finding advanced the timeline for the formation of Earth's oceans much earlier than previously believed. It is possible that this occurred within 200 million years after the formation of the planet. Prior to this discovery, researchers held the view that the early Earth existed as a molten sphere for an extensive period, spanning hundreds of millions of years. The zircons indicated that the surface had cooled sufficiently to support rain, rivers, and oceans in a surprisingly short time frame. This insight transformed our perspective on habitability, indicating that environments conducive to life emerged rapidly. Every zircon, tiny as a grain of sand, serves as a microscopic record of the moment water first appeared on Earth. Through them, we catch a glimpse of a world where vapor condensed, clouds took shape, and the initial drops of rain descended upon the cooling rock. The inception of the blue planet, as we recognize it now. Once upon a time, vast expanses of lava fields stretched across the continents, rivaling the size of entire countries. Over the course of deep time, massive volcanic occurrences, referred to as flood, basalt eruptions, covered extensive areas of the Earth with layers of molten rock. These volcanic eruptions occasionally persisted for millions of years, creating plateaus that reached thousands of meters in thickness and spanning regions larger than contemporary countries. The Deccan Traps, located in India, and the Siberian Traps found in Russia serve as two striking illustrations. These eruptions emitted vast amounts of gas into the atmosphere, changing climate and ecosystems significantly. As they cooled, they created landscapes of tiered rock and fertile soils that continue to influence agriculture in the present day. To stand atop one of these regions is to stand on frozen lava that once coursed in rivers of fire, reshaping continents. These fields of basalt serve as a reminder that the Earth's serene present conceals a tumultuous past, where vast areas throbbed with magma, and the atmosphere glimmered with the brilliance of volcanic activity. The lava floods have led to widespread extinctions historically. The most significant volcanic eruptions not only transformed continents, but also altered the very essence of life. The gases and ash emitted during flood basalt events can contaminate the air, obscure the skies, and disturb the climate for millennia. Around 250 million years ago, the eruption of the Siberian Traps occurred simultaneously with the largest extinction event in Earth's history, leading to the demise of most marine species and numerous terrestrial organisms. The disastrous emissions of carbon dioxide and sulfur dioxide led to acid rain and global warming, disrupting ecosystems. In the wake of the events, new life ultimately emerged, adjusting to the transformed environment. The cycles of destruction and renewal are intricately interwoven into the Earth's extensive narrative, serving as reminders that even the most catastrophic occurrences lay the groundwork for what follows. Within each extinction, there exists the potential for evolution, a quiet change inscribed in ash and stone. Remnants of ancient eruptions remain concealed within contemporary soils. Throughout the globe, delicate layers of volcanic ash remain embedded in sediment and soil, serving as quiet testimonies to eruptions that took place thousands or even millions of years in the past. Every layer can be linked back to its originating volcano through the distinct chemical signature of its minerals, enabling scientists to correlate remote locations and construct accurate timelines of historical occurrences. Farmers may inadvertently incorporate these ancient ashes into their fields, enhancing the soil with essential minerals and nutrients. In regions such as Italy, Iceland, and Japan, volcanic deposits have rendered the land exceptionally fertile. To excavate this earth is to connect with the past, the remnants of flames reshaped into existence. The ash that previously obscured the sun now enriches the soil, fostering the growth of crops and forests, illustrating a cycle in which devastation gives rise to new life, and the traces of disaster support the steady continuation of growth. The Atlantic Ocean originated as a lengthy rift valley. Prior to the existence of the ocean as we recognize it today, the land that eventually formed Africa and the Americas was united as one supercontinent. Around 200 million years ago, significant fissures started to emerge between them, creating a large rift that became filled with water as the continents gradually separated. Over millions of years, volcanic activity expanded the chasm, giving rise to a new ocean. The Mid-Atlantic Ridge, a site of ongoing crust formation, signifies the initial line of division. Ancient rift valleys, such as those found in East Africa, provide insights into the appearance of the early Atlantic. Deep depressions marked by fault lines and filled with ascending magma. What is now an ocean originated as a crack in the planet's thin skin, demonstrating that even vast seas begin as slender openings in rock that gradually expand until they evolve into realms of their own. The sea floor radiates from the Mid-Atlantic Ridge in a manner reminiscent of a conveyor belt. Deep within the Atlantic, a mountain range remains concealed beneath the ocean's surface, where new crust is perpetually created. Magma ascends through fissures, cools, and displaces older rock in a consistent, orderly manner. As this occurs, the continents on both sides move further apart, propelled by the shifting of the seafloor itself. As the lava cools, magnetic minerals align with the planet's magnetic field, forming striped patterns that capture the history of ancient field reversals. Through the measurement of these stripes, scientists have verified that the seafloor indeed spreads, thereby affirming the theory of dancing continents. The process advances at a rate of a few centimeters each year, subtle yet relentless. This underwater conveyor of creation broadens the ocean, while older crust is drawn down at subduction zones in other areas, ensuring that the Earth's surface remains in a state of continuous dynamic movement. Hydrothermal vents produce deep ocean chimneys on the ocean floor, far below the ocean's surface. At the junctions of tectonic plates, seawater infiltrates the crust via cracks and fissures, It descends until it reaches molten rock, heating to hundreds of degrees before ascending once more, carrying dissolved metals and minerals. As the superheated water erupts back into the frigid ocean, it cools immediately, causing clouds of dark material to rise dramatically, like smoke. These deep ocean chimneys are underwater structures that emit minerals and heat, perpetually undergoing formation and collapse. They construct mounds of iron, sulfur, and various compounds that glimmer softly in the depths. The water around them emits a soft glow from reflected particles, and an unusual form of life flourishes, deriving sustenance not from sunlight, but from chemical processes. Every vent serves as a small universe, a vibrant testament that even amidst perpetual darkness, the Earth discovers methods to exhale, ignite, and create. These vents sustain entire ecosystems in the absence of sunlight. In the absence of sunlight, life thrives in dense colonies around deep-sea hydrothermal vents. In this environment, organisms depend on chemosynthesis rather than photosynthesis, utilizing chemical energy derived from sulfur and methane to create food through the action of bacteria. Giant tube worms, clams, crabs, and fish rely on these tiny producers, creating ecosystems that are truly unique on our planet. Temperatures close to the vents can fluctuate from just above freezing to more than 300 degrees Celsius within a matter of meters, and yet life not only endures, but flourishes. The identification of these ecosystems in the 1,970 seconds transformed our comprehension of biology, demonstrating that life can exist without sunlight, relying solely on energy and water. Researchers currently believe that comparable environments may be present on icy moons such as Europa and Enceladus. The deep ocean floor, previously considered desolate, vibrates with vitality fueled by the Earth's warmth. A collaboration between geology and biology that continues to develop. Minerals in that area create chimneys that rise higher than houses. Minerals are constantly precipitating from the superheated fluids that flow into the ocean at hydrothermal vent sites. As time passes, they build up into impressive chimneys that can soar to heights exceeding 20 meters. These formations ascend as long as the flow persists, with layers of sulfides and other minerals creating complex columns that evoke the grandeur of cathedrals beneath the surface. Some falter under their own burden, only to rise once more. In these formations, metallic ores accumulate, similar to the types that humans extract from the Earth. Their gleaming surfaces are home to vibrant communities of microorganisms and animals, each uniquely suited to thrive in the intense heat and varying chemical conditions. The vents throb like submerged volcanoes, their chimneys emitting a soft smoke in the shadows. They demonstrate that even in the harshest conditions, the Earth creates beauty through pressure and heat, forming intricate structures that only a select few will ever witness firsthand. The magnetic field of Earth has undergone flips on numerous occasions throughout its history. Over the course of its history, the Earth's magnetic poles have undergone numerous reversals, exchanging their positions of north and south. The occurrence of these flips is inconsistent, with some happening after hundreds of thousands of years and others after millions. The origin is found deep within the molten outer core, where swirling currents of liquid iron create the magnetic field. As these currents change, the field diminishes, restructures, and ultimately flips. Volcanic rocks on the seafloor provide evidence of this ongoing flipping, as iron minerals align with the magnetic field during the cooling of lava. Every stripe of contrasting polarity signifies a point in this extensive cycle. Even though a reversal might span thousands of years to fully unfold, life has continued to thrive throughout each of those periods, without interruption. This phenomenon serves as a reminder that the invisible shield safeguarding Earth from cosmic radiation is not static. It is a dynamic entity influenced by the movement of the planet's molten core. Throughout those flips, compass needles would have indicated south. If you were to stand on Earth during a time of magnetic reversal, you would notice that your compass would gradually start to act erratically. Throughout the centuries, magnetic north has shifted toward the equator and then beyond, ultimately aligning itself approximately southward. The changes occur slowly as the magnetic field diminishes, divides into several poles, and ultimately reconfigures itself in the opposite direction. Rocks hold the record of these changes, with their magnetic minerals locked in the orientation that was north when they were created. Examining these ancient orientations has enabled researchers to map out the timeline of reversals and the movement of poles around the globe. While the concept may appear disconcerting, reversals are a common and inherent part of Earth's history. They have not led to mass extinctions or the collapse of the atmosphere. Rather, they unveil the vigor of the geodynamo, the profound hidden mechanism that sustains the planet's magnetic core throughout time. Even now, the magnetic poles shift by miles annually. The magnetic field of the Earth is not stationary. The North Magnetic Pole, previously situated in the Canadian Arctic, is currently moving towards Siberia at a pace exceeding 30 kilometers annually. The drift occurs due to alterations in the molten iron that circulates within the outer core of the planet. As convection currents move, they change the equilibrium of magnetic forces above. Instruments on satellites consistently monitor the movements of the poles, providing updates to navigation systems that depend on their location. The magnetic north shifts over time, whereas the geographic North Pole stays constant, highlighting the differences between the two locations. For the majority, the distinction remains overlooked. However, for scientists, the changing poles serve as a reminder that the shield safeguarding our atmosphere is dynamic and continuously developing. The unseen force that directs compasses also uncovers the gradual, flowing pulse of the Earth beneath us. The Moon plays a crucial role in stabilizing Earth's wobble, influencing the long-term geological processes. The absence of the Moon's stabilizing effect could lead to significant fluctuations in Earth's tilt over time, ranging from nearly upright to sharply angled. This instability would lead to chaotic climate changes, transforming frozen poles into tropical regions, and then reverting them once more. The Moon's gravitational influence ensures that the planet's axial tilt remains stable within a limited range. This stability has enabled the flourishing of long-term geological and biological cycles, resulting in consistent patterns for ocean currents, ice ages, and weather systems. The gravitational pull of the Moon generates tides that play a crucial role in distributing energy throughout the oceans, affecting erosion and the movement of sediment along coastlines. The geological tranquility of our planet, its equilibrium between stability and transformation, is greatly influenced by this quiet companion that orbits above. Each soft wave and flowing season is, in part, a present from the Moon, which has steered Earth's movement for over 4 billion years without failing to keep pace. The Moon's influence on tides shapes coastlines over thousands of years. Every day, the ocean ebbs and flows under the influence of the Moon's gravitational pull on Earth's water. Throughout the years and across centuries, these tides do more than just shift waves. They transform entire coastlines. Tidal forces shape estuaries, expand bays, and transport sediments that create beaches and deltas. The subtle forces at work gradually wear away cliffs and carry essential nutrients that support marine ecosystems. In certain areas, the tidal range surpasses 10 meters, resulting in extensive intertidal zones that shift between land and sea. These vibrant ecosystems serve as essential habitats for fish, birds, and a myriad of invertebrates. Throughout geological history, tides have played a significant role in shaping the formation of continental shelves and barrier islands. The rhythm is timeless and unwavering, connecting the movements of far-off celestial bodies to the designs of sand under our feet. The shoreline we observe today is a dynamic artwork, meticulously crafted grain by the gentle influence of the Moon. Coral reefs are dynamic geological formations composed of calcium skeletons. Coral reefs, while abundant in biodiversity, are also significant geological structures. Every coral polyp constructs a small limestone skeleton, and collectively, innumerable generations pile these formations upward in pursuit of sunlight. After thousands of years, the outcome is a reef so immense that it is visible from space. The Great Barrier Reef, for instance, extends over 2,000 kilometers, constructed layer by layer by its living architects. As corals perish, new ones emerge on their remnants, perpetuating the cycle. These formations act as natural defenses for coastlines and function as historical records of the ocean, capturing temperature and chemical data within their layers. Fossilized reefs narrate tales of ancient oceans that once enveloped present-day continents. Each coral colony serves as a biological community and a geological monument, a living rock that breathes, grows, and holds the history of the oceans that have formed our planet. Certain coral reefs have existed for a longer time than numerous mountain ranges. Underneath the tranquil waters of tropical oceans, there exist reefs that have been developing steadily for millions of years. Some started to take shape during the time when dinosaurs were still present on the planet. Throughout geological history, entire mountain ranges have emerged and worn away. All the while, these submerged formations have steadily grown. Their cores consist of compacted limestone, created from the remains of billions of tiny organisms. As sea levels fluctuated, reefs adjusted, moving upward or shifting toward the light. Fossilized remnants of ancient reefs are now found in deserts and atop mountains, serving as evidence that what was once ocean has transformed into land. The resilience of coral reefs reflects the ongoing story of our planet amid turmoil. Their intricate structures marking the passage of both life and Earth's history. Every one stands as a monument of existence and rock, predating civilization, predating mountains, a vibrant connection across the ages of Earth's evolving narrative. Desert dust has the potential to fertilize vast rainforests, even those located across oceans. Small particles of mineral dust, originating from the vast deserts of the world, journey thousands of kilometers through the atmosphere, propelled by winds that traverse continents and oceans. A significant portion of this dust ultimately settles on remote ecosystems, providing essential nutrients. The Amazon rainforest relies on phosphorus-rich dust that is blown from the Sahara annually to restore its soils. Tropical rains would wash essential minerals away without it. These airborne particles create connections between ecosystems that may appear disconnected, bridging arid wastelands and vibrant jungles. Satellite images have revealed extensive plumes traversing the Atlantic, glistening in sunlight before descending as unseen sustenance. Every grain serves as a geological wanderer, a piece of rock that departed from one environment to nourish another. In this serene planetary interaction, deserts and forests unite in a perpetual cycle of erosion, wind, and rejuvenation that encompasses the whole Earth. Earth's rocks hold minuscule pieces of stardust. Within specific meteorites and ancient terrestrial rocks, there exist tiny grains that came from dying stars, predating the formation of the solar system. These tiny particles of stardust endured the collapse of the gas cloud that gave rise to the sun, ultimately contributing to the material that formed the planets. Their isotopic signatures stand apart from anything found on Earth, clearly indicating an origin that is distinctly alien. By isolating these particles, scientists are able to follow the life cycles of stars, observing their formation and their dramatic conclusions. Every grain holds atoms created in the heart of stars, a testament that all on our planet, ourselves included, originated from the universe. These ancient fragments connect different eras and realms, serving as a reminder that geology extends beyond our planet, woven into a cosmic narrative of matter, perpetually evolving through cycles of creation and decay. Gold and platinum originated from ancient meteor impacts. The valuable metals that shine in jewelry and technology did not exist in Earth's original crust. In the process of the planet's formation, the majority of its gold, platinum, and other heavy elements descended into the molten core, The metals we extract today were brought to Earth by meteorites during a time of heavy bombardment over 4 billion years ago. The impacts dispersed metallic fragments throughout the surface, enhancing the upper crust with riches created in cosmic explosions. Each gold vein or platinum deposit represents a celestial legacy, the remnants of explosive occurrences that once illuminated the solar system with flames. Wearing or holding a piece of gold connects you to the memory of that ancient rain of metal from the stars. This represents a concrete connection between the chaos of the cosmos and the elegance of our planet, embodying a blend of universal history etched within the very fabric of rock. Certain impact craters have undergone such significant erosion that they are nearly undetectable. Throughout millions of years, the forces of wind, water, and tectonic activity can effectively eliminate almost all evidence of a meteor impact. A vast circular crater starts to fill with sediment over time, its rim becoming softer and its scars concealed beneath lush forests or expansive seas. However, the evidence persists within the stones: fragmented quartz, liquefied minerals, and concealed circles of broken crust that indicate a tumultuous beginning. Researchers employ satellite imagery and magnetic surveys to reveal these concealed marks, numerous of which previously supported lakes or entire cities oblivious to their celestial origins. Ancient craters have been found beneath younger geological layers in North America, Africa, and Australia, with some dating back billions of years. The subtle presence of these formations illustrates the planet's ability to recover, gradually softening even the most profound scars until they blend seamlessly with the surrounding terrain. A significant impact might have initiated the era of the dinosaurs. Approximately 200 million years ago, a significant asteroid might have collided with Earth, close to present-day Canada, aligning with the Triassic extinction event. The impact unleashed a tremendous amount of energy, causing the skies to darken and sparking wildfires across various continents. Subsequent volcanic activity occurred, leading to significant fluctuations in global temperatures. A significant number of reptile species faced extinction, whereas dinosaurs, which were more suited to the evolving environment, started to take over. The crater, though worn down by time, still holds remnants of molten rock and shocked minerals, narrating a tale of destruction and rebirth. Events of this nature have consistently altered the trajectory of evolution, eliminating certain lineages while paving the path for others. Following devastation, ecosystems find equilibrium, and completely novel life forms arise. Emerging from the turmoil, the formidable reptilian sovereigns of the Mesozoic ascended to dominance, transforming the biological landscape of Earth for countless millennia. One might have brought it to a close. 66 million years ago, an asteroid, approximately 10 kilometers in diameter, struck what is now the Yucatan Peninsula in Mexico, unleashing energy comparable to billions of atomic bombs. The impact caused the rock to vaporize, sparked global wildfires, and released a significant amount of dust into the atmosphere, which blocked sunlight for years. Photosynthesis ceased, food chains disintegrated, and over 70% of species disappeared, including the Nanavian dinosaurs. The crater it created, Chicxulub, is still concealed under layers of limestone, yet it retains its shape in perfect preservation. Under its edge, there is proof of tremendous heat and pressure, a preserved testament to one of Earth's most tumultuous episodes. From that extinction emerged the rise of mammals, leading to the eventual appearance of humans. The event that concluded one era initiated another, illustrating the inextricable link between destruction and creation in the narrative of the planet's continuously evolving cycle of transformation. The surface of the Earth is marked by concealed remnants of past impacts. Although numerous impact craters can still be seen, many more are concealed beneath oceans, deserts, or more recent rock formations. Geologists uncover them by examining slight gravitational and magnetic irregularities that reveal circular formations beneath the surface. Some of these concealed marks indicate locations of impacts so old that they trace back to the planet's primordial ages. During that period, Earth faced a barrage of impacts that transformed its crust and possibly brought the vital water and carbon necessary for life. These scars, though hidden, form the basis of our journey, the subtle proof of a chaotic early existence in the universe. Every discovery serves as a reminder that our seemingly stable world has faced unimaginable violence. As time passed, the marks were gradually erased by erosion and the movements of dancing continents. Yet within the depths of the rock, the memory lingers, patiently awaiting those who are attuned to the whispers of stone. Even now, space dust contributes hundreds of tons of new material daily. Our world continues to expand, piece by piece. Each day, minuscule particles of cosmic dust traverse the vastness of space and enter Earth's atmosphere, igniting momentarily as meteors or quietly landing on land and sea without notice. It is estimated by scientists that over 100 tons of this material builds up each day. The majority of it originates from comets and asteroids, releasing fragments during their orbits around the Sun. In Antarctica and atop rooftops across the globe, collectors have assembled tiny spheres of this interplanetary dust, their metallic surfaces shimmering under the scrutiny of microscopes. Throughout billions of years, this accumulation has gradually enhanced Earth's mass, despite the fact that erosion and the loss of gases have diminished it somewhat. These particles serve as reminders that our planet is intertwined with the vast cosmos, perpetually engaging in the exchange of matter with the surrounding universe. A soft, unending cascade of stars descending upon our planet. Geology connects each mountain, ocean, fossil, and living organism into a single narrative. The exploration of Earth's past shows that everything is interconnected. The very forces that elevate mountains also agitate the oceans, transform rocks, and create the essential conditions for life. Fossils reveal the ways in which climate and geography influenced evolution, whereas minerals document the profound processes that shaped the continents. Each river holds the history of erosion, and every grain of sand was once part of stone. Throughout billions of years, the continuous cycles of plate movement, volcanism, and weathering have intricately intertwined to create a seamless narrative that links land, life, and time. The narrative is expressed through the lens of geology, the narrative crafted in layers below us. It serves as a reminder that the world is simultaneously timeless and vibrant. All that we observe and interact with is involved in a continuous process of change. By examining the Earth, we are uncovering the planet's own story. The stones underfoot serve as the Earth's history, etched in solid form. Each pebble, cliff, and mountain tells a story in the expansive journal of our planet. Embedded in their grains are chronicles of primordial oceans, volcanic outbursts, ice ages, and the gradual movement of land masses. Radiometric clocks determine their ages, whereas fossils and mineral patterns disclose the climates and organisms that preceded us. Rocks retain the memories of pressure and heat, floods and droughts, as well as creation and decay. United, they create the magnificent repository of history, the proof that the universe is perpetually in flux while remaining infinitely tolerant. Being on firm ground gives a sense of stability. However, we are, in reality, positioned at the forefront of history unfolding, a crust that is perpetually forming, breaking, and then reforming. Listening to the Earth reveals its deep, silent history, the whispers of stone capturing the tale of a world that continuously evolves, expands, and reflects on its own history. The ground below is in constant motion. Even now, while you find your peace, the Earth rotates gently beneath the stars that once shaped the very minerals in your bones. Underneath the still surface, liquid rock moves in perpetual rhythms, molding land masses that glide like gentle wisps across a vast expanse of Earth. Geology teaches us that transformation can occur quietly. Much of it speaks softly. Mountains ascend piece by piece. The vastness of oceans surpasses the limits of memory. Each pebble, each crystal, Each grain of sand holds the imprint of an immense timeline, making our own narratives appear as mere fleeting moments of brilliance. Those flashes are indeed woven into the same pattern, embedded within the very fabric of the planet. Deep within the Earth, pressure accumulates. In another place, it relaxes, and a fresh rock embarks on its lengthy metamorphosis. High above, the wind erodes stone into dust, and that dust travels across oceans to nourish life. All that has existed transforms into something fresh once more. The Earth inhales with the steady pulse of rock, and we inhale alongside it, often unaware. Consider the paths you have traversed, the crunch of gravel underfoot, the texture of a cliff's edge, the gentle heat of sand in your grasp. Every one of them narrates a tale, crafted from minerals, molded by the passage of time and the influence of touch. The world is vibrant beyond what meets the eye. It exists in its own essence, transforming memory into substance, transforming silence into shape. As you gently transition into slumber, allow that thought to permeate your mind like rain, nourishing the earth. Envision the profound rhythm of the earth below, timeless and unwavering. Allow it to calm your mind and ease your breath. You play a role in this narrative as well, a fleeting instance in an expansive world that retains all memories. If you appreciate these serene travels, I encourage you to like, subscribe, or share your thoughts in the comments below. It assists others in discovering their path here as well, one drowsy spirit at a time. At this moment, simply take a breath. Allow your eyelids to feel weighty. Allow the earth to embrace your ideas. Calm, enduring, and timeless. And as you drift off to sleep, remember that Earth has existed slowly for billions of years, without haste or stress. The silent layers of rock remind us that everything will be all right with time. If this video helps you relax and fall asleep more easily, don't forget to subscribe to the Sleep Science Top 1 channel to continue your journey with gentle science every night. Good night, and let the earth whisper lullabies to your dreams.